Hi, I am Shashank Kumar Pandey. I am studying Computer Science and Engineering at Vellore Institute of Technology, Chennai. I have done a research on multi-level feedback queue scheduling algorithm. You must be thinking what is multi-level feedback queue and where it came from, why it is needed. To understand about multi-level feedback queue, you must first need to know about the operating system. Nowadays, most of us are using various smartphones and laptops. Every smartphone or laptop or say a desktop has an operating system. You must have heard about iOS, Android. These are examples of mobile-based operating system, whereas Windows, Linux, these are examples of computer-based operating systems. An operating system is generally a resource manager. We all do multi-programming, that is various tasks on same time in our phones and laptops. To do any task, a process has to be executed, and to execute the process needs to utilize the resources that are available. Here comes the role of the operating system. The operating system allocates resources to various processes according to some scheduling algorithms. Scheduling is basically allotment of resources to various processes by the operating system. Operating system cannot allocate resources to processes randomly. Resources should be allocated in such a way that every process has equitable share of resources. That is, fairness should be ensured. It should not be like the operating system wishes to give this one process a more amount of resources and other processes it doesn't provide the time to utilize the resource. There should be fairness of resources that are allocated. Priority should be given to most important processes. Efficiency should be ensured. No process should face starvation for resources and lead to deadlock. Means a process which is waiting for its turn to utilize the resource, it should wait for a finite amount of time. And it should not be that it is waiting for an infinite amount of time. Time should be bounded that this after this much time this process will utilize the resources. And if this condition is followed, then it will avoid deadlock. To ensure proper allocation of resources, the operating system follows several scheduling algorithms. Multi-level feedback queue is also one of those scheduling algorithms. Time-sharing scheduler implements this algorithm. You must have heard of the Mac OS and Microsoft Windows. These both can be regarded as examples of the broader class of multi-level feedback queue schedulers. This scheduling algorithm is intended to meet the design requirements for multi-mode systems, that is, to give preference to short jobs. Short jobs are the jobs which need lesser time for completion, or in other words, we can say that which will take lesser amount of time to utilize the resources. In next, multi-level feedback queue gives preference to input-output bound processes. Input-output bound refers to a condition in which the time it takes to complete a computation is determined by the period spent waiting for the input-output operations to be completed. In simpler words, more time is spent requesting data than processing it. Multi-level feedback queue separates processes into categories based on their need for the processor. The multi-level feedback queue scheduler was first developed by Fernando J. Corbato in 1962, and this work, along with other works on multilinks, made him the winner for the Turing Award. Unlike other scheduling algorithms, multi-level feedback queue scheduling allows a process to move between queues. This movement is facilitated by the characteristics of the CPU burst of the process. Burst is duration. If a process uses too much CPU time, it will be moved to a lower priority queue. That will it will be moved to the back of the queue. This scheme leaves input-output and interactive processes in the higher priority queues. In addition, a process that waits too long to a lower priority queue may be moved to a higher priority queue. This form of aging also helps to prevent starvation of certain lower priority processes. Thank you.